via Zoom, levadas a cabo pelo Instituto de Altos Estudos da Academia das Ciências de Lisboa. Hoje temos connosco o professor Christopher Bernido, que nos vai falar sobre um tema de suma importância: bypassing teacher shortage in optimized learning. Good afternoon, everybody, and welcome to these conferences of the Institute for High Studies of the Academy of Science of Lisbon. Professor Christopher Bernido, it is for me a great pleasure to receive you in the program of Institute for High Studies and a privilege to attend your conference on a topic of most importance and actuality. Thank you for coming and bring us your ideas and experience in this so important subject as bypassing teacher shortage in optimized learning. Thank you. I pass to Professor Vilela Mendes to do the presentation of you, Professor Bernido. Please, Professor Rui Vilela Mendes, you have the floor.
Okay. Thank you, Professor Suman. It is my pleasure to present Professor Christopher Bernido. Professor Christopher Bernido is a mathematical physicist from Philippines, and he has done very advanced work on quantum mechanics, quantum field theory, a powerful technique called the Feynman path interval. But in addition to his achievements in theoretical and mathematical physics, he dedicated himself also to education problems. And his career was made partly in the Philippines. He got his first degree in Philippines, but then his graduate studies were made in the United States at the University of Albany, I guess. And then he has also visited extensively to Germany. He was a fellow of Humboldt Foundation, and he has worked also at in many places like Trieste and so on. And he was for, I don't know how many years, but 4 or 5 years, I don't know. He was president of the Physical Society of the Philippines. He was a director and founder of a research center in theoretical physics, and also president of a large institute foundation. And now he's a member, he's also a member of the National Academy of Science of Philippines. And in addition to all his achievements as an outstanding researcher, he dedicated his attention to education. And in collaboration with his wife, Maria Vitória Bernido, who unfortunately is no longer among us, they developed a fantastic program called the Dynamic Learning Program that is a real achievement, mostly in the two ways. It's, in one end, it can be applied to locations, to children that live in locations which don't have access to good schools. And also the methods, the dynamic learning method allows these children to develop some good habits of responsibility. And it is our pleasure and privilege to have today Professor Bernido speaking to us about this fantastic teaching program. Please, Christopher Bernido, your floor.
Thank you very much for the kind introduction, Professor Vilela Mendes. And first of all, I'd like to thank Professor Maria Salome Paez, head of the Academy of Sciences here in Lisbon, for the kind invitation for me to share something, our experience in education. And thank you also to Professor Vilela Mendes for the arrangements. So my talk will be bypassing teacher shortage in optimized learning, because let's start with this situationer. There is actually an emerging educational crisis, and this crisis has been going on for decades. There's a emerging lack of qualified teachers in STEM, which is science, technology, engineering, and mathematics. and also other subjects as well beyond STEM. And we felt this for a long time. I'm from the Philippines. For decades, countries like Australia, Canada, and USA have massively recruited teachers from our country, and we also suffer from the same shortage of teachers actually. And just to give an example, in Germany, for example, currently there are 30,000 vacant teaching positions, and it is estimated that these unfilled teaching positions will increase to 80,000 by 2030. So if we have to do something, it should have been done yesterday, I think. Also, if we rely only on purely online learning, as we have experienced during the pandemic, there are quite a number of inattentive and unengaged students, which makes learning difficult. So we have to also overcome that aspect. And the fear of lack of teachers is that parents might end up teaching their children, and for some subjects they could not really do it because it's a little bit advanced. So what I'm going to talk today is about a program which could bypass all of these potential problems. We refer to it as the dynamic learning program. This was started in 2002. My wife and I were running high school actually in the Philippines, and we were encountering the same problems. And so we have to bypass a lot of problems which are now very apparent in today's landscape. The DLP, or Dynamic Learning Program, it's a systems approach to process-induced learning. I'll discuss to you what we mean by process-induced learning. It incorporates 21st century skills like critical thinking, problem solving, collaboration, and communication, which are essential for the fourth industrial revolution. It has been applied in our country at the elementary, secondary, and college levels. So let me give an overview of this program before we dig deeper into the components. Just to give in one page what the CVIF Dynamic Learning Program is all about. The hallmark of the DLP is independent learning. So the students will be learning a new topic independently, 70 to 80% of the time, and teacher intervention is limited to 20 to 30% of the time. And sometimes the teacher intervention can even go to zero. We will discuss something about that later on. And this could be done with or without face-to-face classes because of our experience during the pandemic. So when the pandemic struck in 2020, one of the DLP implementing schools in the Philippines sent me a message, and he said, thank you very much, because even if there's a lockdown or shelter in place, we had a smooth transition to the lockdown scenario because the students were already used to independent learning, and we have a scheme to bypass crises like the pandemic. So let's look at the DLP program closer. Of course, you can do this with or without face-to-face interaction. It doesn't matter. This program was started in 2002. So at that time, there was, of course, face-to-face interaction, face-to-face classes. And so, but then it turned out to be applicable also during the pandemic. So on the left, this is what we mean by process-induced learning. The subject teacher prepares learning activity sheets. So I'll be using the acronym LAS, which means learning activity sheets. These are bite-sized, one-page learning activity sheets, and this will be given to each student in the class or during the pandemic at home. And the student will have to, one of the rules of the DLP is that there is no prior lecture. When a new topic is being introduced at any grade level, for any new topic, for any subject, there is no prior lecture. Okay, that's one of the rules of the DLP. So no introductory lecture is needed. And then what the student accomplishes individually will now be sent back to the subject teacher. So the role of the teacher is actually shifted. Before, in the traditional, the teacher would be lecturing 80% of the time. But in the DLP, the role of the teacher is in the assessment. They're like medical doctors who would be diagnosing the sickness of the patient. So this is the loop. It's process-induced learning. It's not in contrast to teacher-induced learning. So it's not teacher-induced learning, but it's process-induced learning through the help of this LAS, or learning activity sheets, which is, of course, in contrast with the conventional, where, especially during the pandemic, the burden of learning was shifted to the students because they were just sending all these bulk materials to be studied by the students. And of course, these materials were meant to be lectured. So essentially, this is the process-induced learning. And let's look at the components of this CVIF DLP. So there are 4 essential components of the DLP. One would be the parallel learning classes. This essentially would implement a 0 to 20% teacher intervention. So it's structural, okay? It actually makes it impossible for the subject teacher to lecture more than 20% or 30%. We'll see that in a moment. And then a crucial component also is the activity-based learning by doing, no introductory lecture, and they will be writing. The students will be writing and copying, and we'll talk about that later also, the benefits. And then, of course, to teach them organization, they have to compile everything in the comprehensive portfolio. And we also have strategic rest, because in some countries, especially in the East, students are burdened by a lot of homework. So here we have a no homework policy. Okay, so let's talk about the components one by one. Let's start with the parallel learning classes. What is this parallel learning classes? Okay, this actually allows the students to explore independently. So here I have a diagram. You can think of this section 1, section 2, and 3 as 3 classes. Now, suppose I'm a chemistry teacher. I was assigned the subject of chemistry to teach 3 sections. In the traditional scheme, what would normally happen? Maybe I will teach section 1 from 8 to 9 in the morning, section 2 from 9 to 10 in the morning, the third section maybe 2 to 3 p.m. So it's sequential. So it's very different. Now, in the parallel classes scheme of the DLP, the chemistry class will be held at the same time, 8 to 9 a.m., 1 hour only. So that's why it's parallel. So effectively, what the expert teacher or chemistry teacher does is he or she will move from one section to another. So you see, structurally, it becomes impossible for the chemistry teacher to teach 100% or stay 100% in one section. So with a parallel classes scheme, whether the teacher likes to lecture or not, or whether the teacher is prepared or not, or disciplined or not, he or she has to move from one section to another. So automatically, since the teacher cannot bilocate or trilocate, automatically the teacher intervention for each section is limited to 20 to 30% of the class time. So we did that to actually remove the teacher from the classroom. It reminds us of Maria Montessori, wherein he said, if only I could tie down the hands of the teachers, because they keep on intervening while learning is ongoing. While the student is exploring and enjoying the topic, the teacher keeps on intervening. So this parallel classes scheme would pull out the teacher from the classroom automatically, structurally. If in a school there are more than enough teachers, then the expert teacher could be outside, and there would be facilitators in its classroom. And the expert teacher will just choose which section or classroom he or she would like to enter or intervene. Now here there are two names of a teacher here: teacher, facilitator, and expert teacher. Well, the expert teacher is easy to understand. They are the regular subject teacher for the period. It could be chemistry, it could be physics, it could be mathematics. But who are the facilitators? In our school, for example, 8 to 9 in the morning, it's science time. That means grade 7 could be doing physics, grade 8 could be doing biology, and so on. So 8 to 9 in the morning, simultaneously, parallel, it's science time. During 8 to 9 in the morning, what is the language teacher doing? What is the physical education teacher doing? What is the other teachers not in science doing? They're doing nothing. So their role from 8 to 9 in the morning would be facilitators. The rule is that facilitators should not intervene when it comes to content matters. The facilitators are just there for classroom management, because after all, these are still minor. The students are still minor. And so the facilitator would just do some classroom management, make sure that the students are accomplishing the learning activity sheets. Now, of course, in the afternoon, when it is language time, what's the science teacher doing? The science teacher will be the facilitator during language time in the school. So those are the roles of a teacher in the DLP. Okay, so the parallel classes scheme is actually the key in a sense that there's an analogy in medicine. In case in the past you have been admitted to a hospital and you stay there for 2 or 3 nights maybe, you have probably observed that the doctor is not with you 100% of the time, right? The doctor will just enter the room with all the residents together with the doctor, and he or she or the doctor will just be with you for maybe 10 minutes. And then they would, the doctor would check up on you, recommend on you, and then the doctor leaves. The doctor leaves and goes to another patient, and then goes to another patient, goes to another patient, because when the patient is still healing, it is not important for the doctor to be beside the patient. When the student is still learning, it's not really important for the teacher to be inside the classroom. So if you want to run your hospital efficiently, you allow the doctors to move from one patient to another, and it is now when the doctor is away, it's the nurses who takes the blood pressure, the oxygen, and so on and so forth. Those would be the facilitators, for example. So that's in medicine. And I also observed when I was young, especially, I observed a chess game where a chess grandmaster has 20 simultaneous opponents. For me, as a young person, I was really amazed with that. But what actually happens? Well, board 1, the chess master looks at the pieces, and because he's a chess master, in 1 minute, he could make the move while the opponent is still thinking. Then the grandmaster would move to board 2, looks at the pieces. In a glance, he knows the best move, makes a move, and goes to board 3. While the opponent in board 1 is still thinking, the opponent in board 2 is still thinking what would be the best move, until the chess grandmaster could make a complete turn of the 20 opponents, and he goes back to board number 1. So you see, the moral of the story is that while the opponent of the grandmaster was still thinking, it's not important for the grandmaster to be in front of board 1 while the opponent is still thinking. He can move around. He is the expert teacher, so to speak. And so it's the same in education. The teacher need not be with the students while they are learning. And that's actually what happens in the parallel classes scheme, because the teacher cannot bilocate or trilocate. Chemistry class is all at the same time. So that's the parallel classes scheme. Now, during the pandemic, we made it into a parallel homes scheme because students were learning at home. So, but it's essentially the same philosophy and same essence. So that's the first component of the DLP, parallel classes scheme. So students explore independently for all subjects. There's no introductory lecture before students do the learning activities. And lecture classes, discussions are done only about 1/4 of the time, more or less. Now, let's move on to the next component, which is a very important component, activity-based learning by doing, because when the subject teacher is not inside the classroom, what would the students be doing? They will try to accomplish the LAS, or learning activity sheets. These are activity-based multi-domain learning. It's learning by doing, discovery approach, problem solving, active, not passive, and everything has to be in school. Because there's a prior lecture, so it's discovery approach. So I'll give an example of an LAS. But the basic structure of the learning activity sheet is that one page, one concept. Because after all, the LAS is addressed to the whole spectrum, the challenged learners, the advanced learners, and those in the middle. So it has to be digestible by everyone, including the challenged learner. So the basic structure is that there's a concept digest for that topic you want to introduce. There's an example illustration and some question and problems at the end. So only they should fit into one page. And if you encode it, it should be font 14, because one page font 8 would defeat the purpose. So let's show an example of an LAS. First, a simple example and another example. So this is the structure. We have the activity title and the learning target and a short concept digest of the topic, some example or illustration, and you end the LAS with some questions and exercises. And the students have to copy this. It has something to do, you see, one of the problems of education is motivation. In the traditional setting, the teacher has to do some song and dance to motivate the students, right? But these adolescents, they know that the teacher is doing song and dance to motivate them, and they might simply decide not to be motivated, right? So you have to overcome that. So in the DLP, first 5 minutes, the blank activity sheets are distributed, and then they start to copy by hand the LAS. They copy the activity title, they copy the learning target, and then the short concept digest. You see, in the traditional, they have this teacher's plan of what to do. And normally, the teacher's plan is known only to the principal. The students do not know that. But here, even the student knows the learning target. Even if that's the only thing he or she would remember, at least he should remember the learning target. So this is about the storm surge. It's very short, and it gives you the structure of the LAS. Now, you might say, can this be done for physics or calculus or programming? Or yes, it can be done, and it has been done for the past decade in our school and by some other schools. I'll give you an example of pre-calculus activity. Okay, this is an example. Since I'm using the PowerPoint, this LAS would occupy 2 pages. But when you do it in an LAS, it's just 1 page. Okay, activity title, the geometric interpretation of the integral. Learning target, they have to copy this, the students have to copy this, to interpret an integral as the limit of a sum of areas. So now they start copying this. In elementary and junior high school, we learned how to calculate the area of plane figures such as squares, rectangles, triangles, circles. How do we find the areas for objects with irregular shape? Let us consider the following examples. I have 3 examples, and the third one, of course, would deal with calculus. But first example, given a regular polygon on the right, we obtain its area by dividing it into triangles and adding the areas of triangles. So this polygon would have 6 triangles, and everybody knows how to get the area of a triangle. So just add the 6 triangles, and he or she would get the area of this funny shape polygon. The area of a polygon formed, the second example, formed under a linear function from x equal to a to x equal to b. So you're being asked to find the area of the blue shaded blue area. Now, one trick is we may divide this blue area into a triangle and a rectangle, and you know how to get the area of a rectangle and a triangle, and then you add it and you say, lo and behold, I got the area of that area under the arrow. Now, the third example area under a curve from x equal to a to x equal to b. This is actually, so they would copy this. This is where calculus is necessary. Okay, so we first approximate the area by dividing the region into several rectangles of heights m1, m2, m3, and widths delta x1, delta x2, delta x3. Okay, then you get the area of each rectangle and then add the areas of the three rectangles. So we have, for example, rectangle 1 area plus rectangle 2 area plus area of the rectangle 3, which is simply the height times the width. And then this may be written using a symbol which you often see in a calculus book. Open any calculus book, and you would find this funny sigma to represent a sum. So this would introduce them to the notation. So this addition of three rectangles can be written as sum, as I goes from 1 to 3, which is represented by this. So now the next question at the end of the LAS is actually to prepare them for further LASs, which says that how can we improve our approximation for the area under the curve? So they would think about that. But of course, if you have taken calculus, you let the number of rectangles go to 100, 1,000, infinite number of rectangles, and then you would more or less get the accurate area of the under the red curve, and the summation would change sign. It would be an integral. So this is an example of an LAS, no prior lecture, right? And the reason for no prior lecture is we want to create holes, to create questions in the mind of the students before the teacher intervenes. Okay? So sometimes when the expert teacher comes in at the end, comes into the classroom, the students are very, very attentive because they would like to know if what they did was correct, if they understood it correctly. And sometimes they get impatient because the expert teacher is not coming into the classroom quickly. Well, that's part of the psychological game with the students. So it's a problem of motivation. They become motivated, and when the expert teacher enters the classroom, they are actually quiet. Teacher does not have to do song and dance in the DLP. Okay, so that's a second component actually in the dynamic learning program. So any required competency, the philosophy is that a complex task can always be divided into much smaller steps. Step-by-step series of learning activities build up toward a more elaborate concept. Maybe LAS1 would just be the definitions of the technical terms to be used in the succeeding LAS. Because sometimes the problem of learning is the block is the use of technical terms, technical words which they do not understand. So in the LAS in our school for any subject, we also have some small box for vocabulary. Okay, so that's the learning activity sheets. And this step, activity 1 to activity 2, should always be avoided, because if this happens, very quickly the student will disengage and the class would become noisy. Okay, so you would know if they have disengaged if the students have become noisy. They've stopped answering. Okay, so this is some picture in two schools actually, in our school and another school in Davao, Southern Philippines. So you see, the students are not looking at the teacher. The students are not looking in one direction. The students are busy trying to accomplish the task explained in the LAS. So it's learning by doing 80% of the time. And this right-hand figure are actually the portfolios. This is a physics portfolio, but we encourage them to color and to make designs, because when they color and make designs and borders, the anxiety of the students go down. You know, to learn physics, to learn math, anxiety is a bit high. But when they start coloring, the anxiety goes down. And when anxiety goes down, learning goes up. Okay, so in the CVIF DLP, we often say that an ideal learning activity is an activity where zero teacher intervention is needed. It's so well designed that when the students copy, I mean, they have answered the question because it's so simple. And we often tell the teachers that if the students have accomplished, 80% of the students have accomplished it correctly, don't lecture anymore. It will only bore them. Go on to the next LAS. So an introductory lecture is not allowed in the DLP for each LAS. It develops critical thinking, comprehension, problem-solving activities, very suitable for the fourth industrial revolution or the 21st century, where it is expected that an individual will be learning 3 or 4 different skills in his or her lifetime because of the changing technological landscape. So it's independent learning. Okay. Now, the writing by hand. Why the writing by hand? It looks medieval, right? Very medieval. But actually, this would probably cure the habits of the youngsters nowadays, wherein they just copy and paste, look at their cell phone for 2 hours, and so on and so forth. Writing engages the students during the first 5 minutes. The teacher does not have to do song and dance. You know, the LAS is flashed or written on the blackboard. The students will copy. Copying is so easy, right? Copying is so easy. And so even if the student is lazy, they would copy. Even if the student is not motivated, they will copy. Even if the student is not disciplined, they will copy. It's so easy. And then once in a while, they hit a word in that concept digest which interests them, which catches their attention, and that's it. So let's see this scientific study. In a paper published in Psychological Science by Mueller and Oppenheimer, they claim that note-taking with a pen rather than a laptop gives students a better grasp of the subject. This study actually involved students from Princeton and University of California, Los Angeles. They went on to say that Mueller and Oppenheimer's study demonstrates that students who write out their notes on paper actually learn more. In each study, those who wrote out their notes by hand had a stronger conceptual understanding and were more successful in applying and integrating the material than those who took notes with their laptops. And reminds me that the secretary in the office, they type letters of the president. The secretary does not really understand what the content of the letter is, but he or she could write it on a laptop. So here, the students will be writing actually this. We started the writing component in 2002, about 20 years ago in the DLP. But it was only in the past decade that scientific studies validated that component of the DLP. So Professor Diane from Collège de France said that when we write, a unique neural circuit is automatically activated. There is a core recognition of the gesture in the written word, a sort of recognition by mental simulation in your brain. It seems that this circuit is contributing in unique ways we didn't realize. Learning is made easier. And that is true. So there is, don't underestimate the writing, because when you write, okay, so there are many studies. You just Google writing and learning or something like that. You just Google, and there are many scientific studies on this. Professor Karen James from Indiana University was even scanning the brain of children to see the effect of writing. Of course, in a book by Eric Kandel, they've already did this decades ago. They scanned the brain when somebody is looking at words. When you look at words, only a small part of your brain is active. When you listen to words like what you are doing now, you're listening to me. Oops, there's only a small part of your brain which is active. When you're speaking words like what I'm doing now, there's actually just a small part of my brain which is active, because when I see a slide, I know what to say. I don't have to think. But when you're copying a learning activity sheet, a topic which you have encountered for the first time in your life, and you're thinking about the relationships of the words, a big part of your brain is active. You know, when you write, it's psychomotor, it's visual, and if you read aloud, it's hearing. So many faculties of your brain is activated. And that's why learning becomes deeper and has actually been shown to give good consequences as far as performance indicators in our school is concerned. And even Professor Hebb, writing the activities activates both the psychomotor and visual faculties of the brain. Professor Hebb said, neurons that fire together are wired together. Remember the plasticity of the brain. Neurons that fire out of sync lose their link. Okay, so that's what we have been doing in the DLP, writing, and as I said, it could bypass the song and dance of the teachers. So let's see, we have done through parallel learning, we've gone through activity-based, and of course, the students will, one LAS after another, they compile this. So they have to learn how to be organized, and they have to compile it in a comprehensive student portfolio. And in our school, it's also color-coded, yellow for math, white for English, blue for science, and so on and so forth. It helps them to be organized. You see, when they apply for employment in the future, the employer would like to get an employee who is very organized. So this act of organizing actually is habit forming, and it teaches them how to be organized, and it will help in their work in the future. And once they compile a new LAS into the portfolio, without knowing, they actually look back. They look at the previous LAS, and without knowing, they're actually reviewing. So there's some, it's a technique in a sense, but it teaches them organization. So everything is compiled there, compilation of all activities, exams, quizzes, concept notes. It's color-coded for subject areas. And it's cumulative scholarship. It's almost as if at a young age, they're already writing a book in their own handwriting. And it has to be in school, because if they bring it home, it gets lost and so on. It gets wet and so on. So that's the third component of the DLP, comprehensive portfolio. Of course, the fourth component is strategic rest, especially in the East. Well, I won't mention countries in the East, but they really, they even have a shadow education after school. But strategic rest is very, very important. No homework, and we have midweek, we have no academic classes. So this DLP, we actually tried it in 2008. You see, our Department of Education had a survey in 1998, and they found out that only 23% of the high school physics teachers were qualified to teach high school physics. And we require, in the Philippines, we require physics to be taught in all high school, but only 23% were qualified. So based on the DLP, we tried to do this learning physics as one nation. We prepared 239 learning activities, which the students will have to copy by hand. And then, since it is assumed that the teacher assigned to the classroom is not a physics teacher, we prepared 18 DVD volumes which are closely tied with the learning activities. And the rule is, they do the activity first, and after that, they watch the related DVD related to that topic. And we had a pre-test, a post-test, and so on, and it was quite successful. So this is, I am a physicist, and sometimes we like challenges. So the question was, what if all the physics teachers would migrate to the US and only one physics teacher would be left in the Philippines? Question, would the students still learn enough physics to do well in college? Our answer, yes, of course, with the help of technology and with the help of the DLP and the LAS. So LAS is crucial, and so on. Okay, so performance indicators. This is in our school. Every year we were given a national exam. It's a nationwide exam. So number of students would be the vertical line. Performance would be the horizontal line. High scores would be on the right. Left would be low score. So we implemented the DLP in 2002. And the baseline data before DLP was that a lot of the students were really doing poorly in terms of the percentile rank. And then we implemented in 2002. By 2006, this was the figure that we were doing as far as the performance of the students were concerned. And you would worry that the bright students on the right might leave behind the challenged learner which is what happened to other schemes of individualized learning. But what we feared did not happen. In fact, in 2009, it was almost opposite to 2001. But my wife, who was the principal at the time, was still worried. He was worried about the tail end, the low performers. Our school, by the way, is, we accept almost everyone. We have a very, very liberal admission in our school. And in fact, we admit non-readers because that's the reality in the Philippines. But somehow, by grade 7, non-readers, but somehow by grade 9, when they're given these national exams, like in 2010 and onwards, nobody scored below average. So, well, what happened to the non-readers and challenge learners? Actually, in the DLP, since it is not teacher-dominated, the students can ask their classmate. Peer tutoring in the classroom is very, very strong. The teacher is in another class subject. So peer tutoring is very, very strong, and that would help the challenged learner. And for the non-readers, actually the writing helps them, because what is writing? It's really saying that this symbol means anything, means something. And so they write and so on. And so we were surprised by their performance by 2010 and so on, succeeding years. Nobody scored below average. So that's in our school. Yeah, so this is the circle means that the graph has been truncated. Nobody was learning below. This was after the pandemic, just out of curiosity. This is a September 2022 Earth Science exam given to the grade 11 students in science, technology, engineering, and math. It's a score 50, total score. And these students had teacher intervention lectures ranging from 10 minutes to a little bit more for the other sections. But this was the performance. So we do keep track of the components of the DLP. Now, in public schools, Department of Education is a public school in the province. There were 162 public high schools which implemented the DLP in 2011. So 162 public high schools, this would be, I don't know, 26,000 students, 30,000 students. They implemented in 2011. Very quickly, the National Achievement Test results went up and the failure rate went down. So it was good indication for, you always ask the question, can it be scaled up? Well, this is scaling up. This involves, 30,000 students in Bohol. And there was also another province in the Philippines, way down south, in Basilan. There were 19 secondary schools which also implemented the DLP. They implemented it at the same time as the one in Bohol. And very quickly, there was a rise in the National Achievement Test. So once they implemented the DLP. So these are just some of the performance indicators. Now, this another school in Davao, a private, we've been talking about public schools in Bohol and Basilan, but this is Davao Christian High School. And you can look at the year, school year. And this is also the percentile rank in their national exam. If you get the percentile rank of 99 plus, that means that you belong to the top 1% in the whole country. By the way, Philippines, 110 million population. Okay, so it's big. So they started the DLP in 2005. So by 2010, 3% of the examinees belong to the top 1% in the whole country. The year after, 19% of the examinees. By the way, this is in mathematics. The year after that, 17%, then 32, then 35, then 37, and then until more than half of the examinees belong to the top 1% in the whole country, and so on. Anyway, you can read this later also. You might ask also the question, well, okay, these students are learning, but can they really do high-level stuff? Again, just a performance indicator. We have one graduate from CVIF from our school in 2005. Ronald Duren is doing marine science at ETH Zurich, which if you Google, the marine science is actually #1 in the world. And he will be graduating this year, marine science PhD. We have also Madeline Naiga. She's doing his PhD in Max Planck Institute in physics. She will also be graduating this year. And Jasha Casadas, for example, got her BS in anthropology from Berkeley. So they can do well. And by the way, these students, they only had 0 to 20% teacher intervention during their high school and absolutely no homework. So questions, what is the guarantee that each student is learning? Answer, the LAS, copied and answered in the student's own handwriting, involves the psychomotor, visual, and when read aloud, the hearing faculties of the brain. With the CVIF DLP as distance learning, especially it happened during the pandemic, how are learning outcomes assessed aside from tests? You see, especially with ChatGPT, right? Now the teachers are in a quandary how to grade their students. But you see, if each LAS is also graded, and you know that it was in the student's own handwriting, you know that those thoughts passed through the mind of the students because it was in their handwriting. So it actually bypasses that fear of new technology that the students would not be learning anymore, and it's just a world of cut and paste. So learning outcomes are assessed every week based on the LAS submitted in the student's own handwriting. And we have seen the benefits of handwriting as shown by scientific studies. So the CVIF DLP, it addresses the learner disposition. You know, hour after hour, there'll be copying the LAS. And so it's habit forming. First 5 minutes, they get a blank sheet of the activity sheet. Then they start copying the activity title, the learning target, the concept digest, and it becomes a habit. It becomes habit. No need of motivational techniques by the teacher. It's just automatic. It's habit forming. And so the 4 components of the DLP addresses the learner disposition, which is a big problem in the 21st century. The DLP addresses shortage of, teachers, because if there are learning activities, they can be done independently by students, 80% to 100% of the time. So it bypasses the limited face-to-face learning and expensive internet connectivity, for example, in our country and other countries where internet can be connectivity. So this is actually my sharing. Hopefully it could bypass the problem of shortage of teachers, even in advanced countries, because as I said, we suffer from the teacher migration to advanced countries as well, and we have to keep on training teachers. So thank you very much. And if there are questions, I could entertain questions from the audience.
Professor Solomé, you are in charge of the host, please.
Yes, please.
Thank you very much for your so interesting and actual talk, bringing us with...
I think you're muted, Professor.
No, I am not muted. No? No?
Yeah, I'm listening to you perfectly.
Yeah? You can hear me? So
I can hear you, yeah.
Okay, so I was thanking Professor for a so interesting talk that you brought to us in a subject that I was thinking on the problems you have in Portugal also, because anytime we have less professors. But my first question was the behavior, as I started discussing with you before, the behavior of the students in Philippines. How could I say? Do you think is similar to the behavior of the young people since very young to the university that are less attentive? Do you have some previous preparation for the students be able to conduct themselves and to learn by doing and by questioning? how are these children prepared to become to the university or to the secondary school to be able to conduct this own development and learning with your method? And also, have you have a need for teachers to know how to interact either as how can I say, as teachers or as helpers? So maybe there is a lot of previous work you have to prepare both students and teachers and helpers to be successful, and so successful as you told us you in your country. Have you tested in another populations from other countries? For instance, in Germany, did you test your method?
Well, outside of the country, I would say not yet. But I would say that thank you very much, Professor, for that very, very nice question. You were actually addressing from the students as well as the teachers. As far as the students are concerned, students from other countries, there are actually universal features in the young people that cuts across nations, cuts across culture. After all these youngsters, all these young people are subjected to the same social media environment. It's now worldwide, it's now universal. And like these scientific studies in writing and others are cuts across nationalities, cuts across different countries. So that's what I could say as far as the differences in, of course, there are cultural differences, but I think there is more overlap in the behavior of students, youngsters in different countries, more overlap than differences because of this globalization. And so my belief is that it could work even with the students, because if you go traditional, it will become harder. It is actually harder. You know, the teacher can talk, but the students might not listen. So things like that. Now, as far as the teachers are concerned, the 20% intervention, whatever the teachers learned in the College of Education, they could still apply in the 20%. So for example, one teacher asked me, how can we do recitation in English if our time is limited, just 20%? So our answer is that there's 1 week, right? So if you have, for example, 3 sections in English, on a Monday, you spend all the time of the period in your English class, do the recitation, while section 2 and 3 are doing LAS. So you do all the recitation on that section 1 on a Monday. On a Tuesday, you go to section 2, do all the recitation and do all the techniques that you learned in the College of Education, while section 1 and 3 are doing the LAS. And then you go on to the 3rd section. The net effect is that in 1 week, the teacher intervention is still limited to 20%, 20 to 30%. So it's the same ratio. I just outlined the basic philosophy, but there's actually a lot of flexibility if one understands the philosophy behind it, the reason behind it. The DLP can actually be flexible as the teacher intervention can, as been seen in the teacher intervention.
Thank you very much.
You. Other questions?
Now if it was Rui that at the end before, who is that one that was before? I didn't realize. Rui, you want to?
Yeah, thank you, Professor Bernido. It was a very interesting talk, and I was most impressed by the neurological evidence that the active learning should apply to everywhere in the world, actually, because the learning is better. That is neurological evidence. One question I have is the following. there is an activity that is very important in physics and chemistry. It is the activity in the laboratory. How do you solve that in your system?
The activity level. Well, you can have the same topic, the same title of the LAS from, if you want, grade 1 to grade 12. But in grade 1, it's what? 2 sentences or something like that, grade 3. And then, so it is in the content that would vary. The structure, the LAS is still 1 page. It's still digestible. But the difficulty of the subject, like in physics, I study classical mechanics in my bachelor's. I study classical mechanics in my master's. I study classical mechanics in my PhD. So the title is the same, but it's the content which is different. It becomes more complicated. There's actually more mathematics as you go up. So essentially, it's the same as you go from one lower grade level to another. You're correct, the LAS, design of the LAS is very, very important. Now, maybe a bit of information. The learning activity sheets of our school is in our website. It's uploaded. These are learning activities from grade 7 to grade 12 in all subjects, including physical education. So that could serve as a prototype. You might have to translate that into your own language, into your own national language. But at least those LAS in all subjects from grade 7 to 12 can serve as a prototype of how to make the LAS. Normally, the pitfalls of new teachers is that when they do the LAS, it goes beyond 1 page. And we tell them that if it goes beyond 1 page, cut it, put a question at the end, and then design another LAS. You can do as many LAS as you want, but just make the one LAS digestible. I hope I answered your question, Professor.
Please do you now. Can you? I don't see. Dr. Bock, can you question?
Yeah, thank you very much. So first of all, one remark, it's not true that it's not done at all outside of the Philippines. So I have this year, for example, an additum, which is an additional class 10, 11, 12, where I do machine learning with school kids, and I tried to do it in a active learning based way. That means what I did actually is to write the notebooks, but I tried to use some sort of DLP to give them something like the inputs, and then they start learning programming and also learning then afterwards how to use machine learning. The only thing is that, and you are right, when you start with this is a big problem, because usually, as it is in Portugal, school kids in Germany behave completely different than if they have learned complete activity-based learning. But this is because not they don't like activity-based learning, just because we try to teach them 40 hours a week, not activity-based. So if they have if you let them loose, then of course they do a lot of things at the beginning. It lasted for about, I would say, 3 to 4 sessions. Right now, what I'm doing actually is I give inputs, help them programming, and cook coffee, and the rest is they're doing completely themselves. So at the moment they are doing, for example, support vector machines for categorization problems, which is something you can do actually in bachelor level, and it's grade 12. So and they really learned that based on the activity sheets, so they can use them. Of course, it's an additional class. Yeah, it's not that what they usually do in the math class, and it's just something like 4 hours a week. But you really need somehow to create the learning environment, and they have to get used to this. What they have to do now, it's much more exhausting for them than the classical frontal, let's say, teaching, right? Because when you are there, they can hide. So if you do the job for them, they can hide. So if they have a 1.5 hour full programming session, they're completely exhausted afterwards, and they have to get used to that. Yeah. And this is something like we also have this for years. I think since about 12 years and doing mathematical modeling weeks, where we have the same thing. We give a real problem to school kids for about 1 week in small groups, and then they really like to solve with their own techniques such a problem under minimal invention of teacher or minimal invention of the experts on the university who are around, right? Since you really like let them work alone, the first 2 days they have really problems to focus on themselves because they don't have guidance. But then they start to somehow have something like a certain swarm intelligence. They work together. It's like Chris said. You can see that we have so there is the group of Martin Bracke in Kaiserslautern. They did actually videotaping about this in groups, and it's very interesting to see the group interaction, how this is going, and how somehow peers of groups are interacting with each other and are really like talking about what they are doing right now and helping each other. Yeah, I mean, it would you also know that maybe from the school, yeah, you would ask your neighbor, how did you do that? And then this is something like an emotional scale, also like Chris said, it stays much more in your brain. Also, based there are neurodidactical studies like Spitzer and so on. You can read that when you have an emotional link to that, what you learn, the learning activity is usually more sustainable. So that's what we also can see in this modeling, active learning modeling projects. The funny thing, or the striking point of that, what Chris is doing, is that you are really like this LAS is really like forming the learning somehow. So you can do this according to the curriculum. And that is something you cannot, for example, do in mathematical modeling, because you could never know what's coming out. They are doing this with their own techniques, and there's coming a model out, but it can be based on that what they just learned, be completely different. Yeah. But these activity learning sheets are a bit more steered learning in that way. So it's actually a quite interesting technique. But as you said, and as you mentioned it, it's very hard to in Europe now to, for example, turn the twist and do a 100% schooling just in this direction. But it's a huge asset if you think about substituting lectures. So in Germany, for example, you have that much percentage of teachers which are just or classes, hours of classes which are not held, or where you actually watch a movie, because there are no experts. But if you would use this dynamic learning program or the LAS sheets in order to bridge that, or you give some people something at hand like we had in the pandemic, so to have something like an emergency case of what happens if the next pandemic is coming. You have a sheet of papers and you can say, okay, with minimal intervention, I do that. That would be a large asset for Europe, and then we can piecewise start to develop if we like to do that. Yeah, but of course, it's at the beginning, and I can completely understand that. It's very hard to think that it works, and it needs some time. So if you just invoke it directly, you will see that you need 3 to 4 weeks to do it, but then it works. So I saw that it works, and I believe it works.
Absolutely.
That's why I invited it.
I understand very well. So I think that you arrived to the end, and again, thank you very much for all of us, that all of you that bring us this so interesting way to solve the problems for education. And if you agree, I would like to have some minutes tomorrow in order to discuss a little bit more in detail with time, because now we arrive to the end of the hour to close the academy. So thank you very much, and see you, all of you, in the next future, and thanks to come and to be with us today. Bye.
Thank you.